Hi, today we're going to do something slightly different. The lesson is divided into two videos, video A and video B. So what you're going to be doing today is you're going to listen to video A, there's going to be some questions, and then you're going to watch video B. There's going to be some questions at the end of video B, and then you're going to send me the answers to those questions. So you're going to watch the first video, do the questions, watch the second video, do the questions, and then send me the answers to the questions from the second video. So that's what we're doing today. So, this is the beginning of gravitational fields. But we're not going to get into exactly what the field bit is until tomorrow. Today we're just going to focus on the gravity bit. I'm going to start by just making sure we all know the difference between mass versus weight. So take a moment, think for yourself, what's the difference between mass and weight? So mass is a measure of just how much stuff there is. Yeah, so the mass of me is all the stuff that makes up me. The only real way to reduce or increase my mass would be to like chop off my arm or something, which makes my mass will go down, or eat loads of donuts and my mass will go up. Yeah? Weight is the force of gravity pulling down on me. So they're different things, they're related as we'll see, but they are different, so just make sure you've got that crystal clear in your mind. So, if we go back to the 1600s, there was this cat called Kepler, and he was a monk. Now, because Easter was defined as the first Sunday after the full moon after the vernal equinox, Christian monks had to keep a good look at the nighttime sky. And Kepler spent years and years and years very carefully, very patiently writing down where everything was in the sky, which means that when Newton came along a bit later, we had fabulous amounts of data to look at. And he had this thought, what if the force between planets was inversely proportional to the distance between them squared? So if you were to double the distance between two objects, their force would drop by a factor of 4. Triple the distance, drop by a factor of 9. So as the distance goes up, the force between them drops really, really quickly. And what he discovered was if he applied this idea, then all the data he'd got from Kepler actually worked really well. And it explained the movement of the planets and the very strange things that we've been seeing in the sky. Because if you actually look at something like Mars, it doesn't go round and round us because we're both rotating. It sort of goes left and right and left a bit, right a bit, and then disappears for a while and then it comes back. It's very odd, but it turned out this law actually explained it very well. And this is how we write it today. And this, and you need to know the name for your exam, is called Newton's law of gravitation. And it states that the gravitational force between two masses is equal to a constant, g, it's just a constant, times the two masses divided by the distance between them squared. So the force would go up as the things have more mass, which you'd expect. Bigger things, more mass, more gravitational force. There's a constant, just to make the numbers work, and it will decrease with the distance squared. Now today's lesson is pretty easy, we're just doing this sort of test, check that it works, but there's 3 questions using this equation underneath the video. Actually do them, and then watch the second video where I'll explain how to do those 3 questions, and then there'll be the questions that I want you to email the answers to me. Okay, do the questions, then watch part 2.